Okay, now the first thing is indices. I'm pretty sure you know all the rules of indices, but just a quick catch up with all of this, okay?
Yes.
All right, so I'm gonna go with a faster pace. Whenever you think I'm going too fast, you can let me know. I'll slow it down.
Okay, sir.
Okay, a to the power m and a to the power n. Bases are same. Two things are being multiplied. I can rewrite them down as a to the power m plus n. And if a to the power m times, divided by a to the power n, then I can rewrite them down a to the power m minus n. If I've got a to the power m times b to the power m, bases are different, powers are same, then I will rewrite them down as a times b whole power m and vice versa. From here, there's an important point that a to the a plus b whole power m is not equal to a to the power m plus b power m. This rule is only applicable for multiplication and division. Like you can't split the powers in addition and subtraction the way you can do here. Okay, and the next is a to the power m over b to the power m. So same rule, but for the division purpose, you can write it down under the same power, or if you want to split the powers with the numerator and denominator, you can do it exactly in the same way. And exactly in the same way, you can't even do it for subtraction purpose. Is not equal to a to the power m minus b to the power m. The next is a to the power m and then a whole power n is same as a to the power m times n. A to the power 1 over n is same as nth root of a. A to the power m over n is same as nth root of a and then a whole power of m, or nth root of a to the power m. Both are exactly same thing. In one of them the power stays in the other one power goes out as a whole power. And then a to the power 0 is 1. A to the power minus 1 can be written as 1 over a. So these are all the basic and important rules about the indices. Okay?
Yes, sir.
All right, so quick go through to the other basics of algebra. One is a factor form. The other form is expanded form. Moving from the factor form to the expanded form is known as expansion, and moving from the expanded form to the factor form is known as factorization. There are two ways you can expand any algebraic expression. One is simple multiplication, like for example, you have x times x squared minus 4x. In this one, you'll multiply this x with each of the term separately. So this is going to give you x cubed minus 4x squared. Okay, now these are the two factors. Now there's another important thing which I would like to discuss here. Over here, you've got two factors. One factor is x, and the other factor is x squared minus 4x. Factors are basically things which are being multiplied. In the second factor, I've got two terms, two separate terms. Terms are being, you can identify the terms, they are separated by addition or subtraction sign. Okay?
Yes.
All right, now this is the expanded form. Over here, I've got two terms, and then each term is you can say it can be further factorized to in by using basic rules of indices. Like the first one can be written as x times x. You don't have to do this, but just explaining you minus 4 times x. So the first term, which is x cubed, has got 3 factors. The second term has got basically also got 3 factors. You don't have to write it down, but just giving expanding your vision or different, giving you a different perspective. Okay, the other method is by using algebraic identities. You can use algebraic identities in order to expand. There are 3 algebraic identities: a plus b whole squared equals to a squared plus 2ab plus b squared. Second one is a minus b whole squared, a squared, the expanded form of which is a squared minus 2ab plus b squared. And the third one is a plus b times a minus b, the expanded form of which is a squared minus b squared. Now you can use either of these two methods in order to expand, but this one is not applicable for all the factors. It only works on the special factors. Special factors as in if you've got x plus 5 whole squared, like these are special factors, means x plus 5 times x plus 5, or there's another type of special factor. You've got exactly same factors with a minus sign between each of the term. Over here, you've got same factors, but both of them have different signs between each of the terms. Okay, so the
Yes.
algebraic identity is only applicable for special types of factors. This method, the first one, is basically known as distributive multiplication. You can use that for any type of expansion method. Now, the next thing, the opposite process, is basically the factorization, which is very, very important. Now, there are different ways you can factorize depending on what type of case you're dealing with. If you've got 2 terms, okay, now the first thing which you need to check is if you can rewrite them down as difference of squares. If you can rewrite the 2 terms as a difference of squares, means there should be a minus sign between the terms, and each of the term can be written as a square of something. Then the factors, you can obtain the factors by applying the third identity in the opposite direction. So the factors will be a plus b times a minus b. If you cannot write them down as difference of squares, then you will take common. Okay?
Yes.
All right. Then you've got a plus b plus c. If the 3 terms combine together, they are quadratic. Then you will do the middle term breaking method. You will factorize them by using middle term breaking method. You can also factorize them by completing square as in by using the first 2 identities. Now these are the first 2 identities I've written down up here. If you are factorizing an expression by using either of them, one thing is for sure that you will obtain special factors. So you cannot use this method for every expression. For example, you've got an expression and after you factorize it, you obtain these factors, x plus 3 times x minus 2. Clearly, these are not special factors. So you won't be able to factorize the same expression by using completing square method. And you won't know that until you have factorized it. So the default method in order to factorize, you should keep it the middle term breaking method. And if the examiner asks you to factorize it by completing square method, then you should go for that one. Okay?
Yes, sir.
Okay, if the 3 terms combine together, they are non-quadratic. the non-quadratic, then you take common. Okay?
Yes, sir.
All right, and then
Sir, could you like solve the one for like completing the square? Cause I I know how to do it, but then I
yeah,
somehow
I'll do
am
it.
not able to get it right.
Yeah, we'll do it. Okay,
Oh,
we will do it. Okay, and whenever you've got four terms, you always take common in groups. Okay, so I'll quickly go through the example of each kind so that we can discuss each of these possibilities. So these are the only possible cases of the factorization. Okay.
yes,
Two
sir.
terms, three terms, four terms. So I'm going to do this one first, where you've got two terms, and if you can rewrite them down as the difference of squares. So for example, you have p to the power 4 minus 16q square. Now, you can clearly see that I can rewrite them. I've got the two terms here, and examiner is asking me to factorize it. I need to rewrite them down in a factor form. Now, I can clearly see I've got two terms and there's a minus sign, so there's a possibility I can rewrite them down as a difference of square, which is correct. I can rewrite each of the term as a difference of square. Okay, so p to the power 4 can be written as square of p squared, and 16q squared can be written as 4q whole squared. Okay.
Yes.
And whenever you have the factors like this, you have a plus b times a minus b. So a in this case is p squared. Whatever you have inside the main square, that's p squared. That's a. And b is 4q. So the factors would be p squared plus 4q, and then p squared minus 4q. That's it. So this was the case where you were able to write them down at the difference of square. Now, for example, if you can't rewrite them down at the difference of square, let's just take the example of that one. So, for example, you have p squared minus 3p squared minus 15q. Now, 15pq, let's just take that one. Now, I've got two terms, although I've got a minus sign between them, but I can clearly see I won't be able to write them down at the difference of squares, so I'll simply go for the common. So 3p is common, p minus 5q, that's it, you've got the factors here. So I've got three factors over here, 1, 2, and 3. Got it?
Yes, sir.
All right. Now, next is um, quadratic over here, the middle term breaking method. Now, quadratic and the middle term. Okay, so 5x squared minus 16x plus 3. Now, whenever you have a quadratic expression, now three terms and you have a quadratic. Now, by default, I will definitely apply a middle term breaking method. Now, what you're going to do is you will multiply a constant term with a quadratic term. In this case, you're obtaining plus 15x squared. Okay?
Yes, sir.
So you need two numbers. When multiplied, you should get 15x squared and with a plus sign. And whatever sign you've got here, the next thing is decided according to that. So if I would have negative 15x squared, I would have put minus here. Okay, I have plus sign here, so I have placed plus in this case. So I need to add the two numbers and get the middle term, which is negative 16x. If I had a minus 15x squared, then I would have said by the difference of the two numbers should give me negative 16x. In this case, I need to add them. Okay, now, can you think of the numbers? It's easy.
Um.
Okay, if you can't, break this, write down pair of possible factors for 15. 1
2 and
times
5.
15, 1 times 15, 3 times 5, and that's it. So 5 add 3, we need to add, okay? So 5 add 3 is not 16. 15 add 1, it is 16, okay?
Yes.
But I need negative 16, so I'll be using both negative. Negative 1x, negative 15x. Negative 1x, add negative 16x. So that's going to give me, sorry, negative 15. Got it?
Yes, sir.
Okay, so minus times minus is plus 15x squared. So I'm adding both with the negative signs. The final answer would be with a negative number. So the middle term will be broken down. Okay, 5x squared as it is. Negative 16x, I will rewrite that down as minus 1x, and then minus 15x plus 3 as it is. This is 4 terms, so I'm dealing with the last case as well here. Okay, 4 terms now. So whenever you have 4 terms, you group them, you take common in groups. From the first two groups, I have x as common, so 5x plus, sorry, minus 5x minus 1. From the last two, I take negative 3 as common. As I've taken a negative number common, so it will change the sign of each of these terms. This term is negative, so it will be positive inside, plus 5x. This is positive, so this is going to be negative 1. So 5x minus 1 times x minus 3. So I've done the factorization. Should I give you one more question?
Sure, sir.
Okay. 3x squared plus 10x minus 8. Instead of you doing it, you can tell me what to do.
Okay, so the sum needs to be plus 10, and the product.
The sum doesn't need to be
Oh no, the
plus 10.
product needs to be plus 10, and
The product, no. Look at this. I'm going to do this question, go through this question again. The first thing is you multiply these two. What do you get? 15x
15.
plus 15x squared. So the product should be plus 15x squared. And this sign tells you if this is plus, then the sum. If this is minus, then the difference. Okay, now what do you get in this case?
Negative 24.
Shabash. Now, what?
So
The product should be negative 24x squared. And then?
the difference should be plus 10.
Shabash. The difference should be plus 10x.
Plus 10.
Nice. All right, think of the numbers. If you can't write down the pairs of possible factors
6 and
of
4.
24, 6 and 4, the difference is 2.
So we'll just do
Okay,
negative 6 and negative 24, or 6 and 4.
negative 6 and negative 4.
Yes.
That's not difference.
Oh,
That's sum.
positive 4. Oh, no.
Even okay, negative 6 and positive 4 is not. Okay, that's the difference again, but that's going to give you negative 2. That's the difference, right? Because they've got opposite sign, but that's going to give you negative 2. All right, the best way to go about it is make a list of all possible factors of pairs of 24. 1 times 24 is 24. 2 times?
12.
3 times? 8?
8.
4 times 6, and that's it. Now, out of these pair, which pair's difference is going to give you 10?
2 and 12.
2 and 12. All right, you need positive 10. So which one of these should have a plus sign?
12.
Right, so it's going to be 12x and negative 2x. Got it?
Yes.
All right, so 3x squared plus 12x minus 2x minus 8. You take 3x as common, x plus 4, and then minus 2 as common, and then x plus 4. I've taken negative sign as common, and both of these terms will have opposite signs inside. Okay?
Yes.
X plus 4 is common, and then 3x minus 2. All right, one more question. Let's just do... 6x squared minus 10x plus 4.
Okay. So the um the product needs to be 6 times 4, which is 24,
Plus
and
or minus?
plus 24. And
Okay,
so
so the product should be plus 24x squared.
and the
And then
sum
sum
should
or
be
difference?
minus 10.
Sum should be minus 10. Excellent. Now, the sum with the minus sign can only be obtained when both of the numbers have a minus sign. Okay? Minus 2, minus 3 is going to give you minus 5.
So
Okay, for this one,
minus 6 and minus 4.
nice. Minus 6x, minus 4x, minus 6x. All right, so 6x squared minus 6x minus 4x plus 4. So 6x is common and x minus 1. Minus 4 is common and then x minus 1. X minus 1 is common and then 6x minus 4. Got it?
Yes, sir.
Okay, now one more question. 15x squared plus 42x minus 9.
So the product will be negative 135.
Nice.
1x
Product
squared.
needs to be negative 135x squared.
And the difference needs to be 42.
Very good. Negative 135x squared, and the difference needs to be 42x. Okay, now the best way is I told you to make a list of possible pairs of products of 135.
3 into 45.
3 into?
45.
Okay.
I think we can use this.
Yeah, definitely we can use this.
So 45 minus 3.
Nice. 45x minus 3x is going to give you positive 42x. Okay. Now 15x squared plus 45x minus 3x minus 9. So 15x is common and then x plus 3. Yeah. 15 times 3 is 45, right?
Yes.
Okay. And then minus 3 is common and then x plus 3. Yeah. So x plus 3 and then 15x minus 3. That's it. So this is how you'll be doing the factorization of quadratic expressions. Okay?
Okay.
All right, now moving on to the next thing, which is cubic and 3 terms. Okay? Which is
Yes.
actually, in short, it's got 3 terms, but it's actually non-quadratic. Okay?
Yes, sir. Could we do one with like completing the square?
Yeah, we'll do that. Because completing square is totally, it's got quite a lot of depth. So we'll be doing that. Actually, let's just do it. Okay, do it. We'll do it. Let me think of the factors. Sorry, expanded form. Let's just start with the easy one. So, for example, you have x squared plus 26x plus x squared plus 26x plus 169. Okay, now this is the expression which will be definitely factorized by using a completing square. As I stated earlier, not all the quadratics would be, you won't be able to factorize them by using completing square method. Now, completing square method, as we are discussing it already, so that's why I would like to talk about it, a little bit about it over here on the side. Completing square is a process. It's not, it has got nothing to do with factorization only, okay? It has some other purposes as well. Completing square is a process which has two possible outcomes. One is x plus a, or you can just, let me just write x plus b whole square. Now, if you get this, then that's factorization. You've got special factors, okay?
Yes.
The other possible outcome is you get something like this, x plus b whole squared minus q. Now, that's not factor. Clearly, it's not factorized, okay?
Yes.
So completing square, do not associate it with just the factorization. It's a process, and it depends what type of expression you've got, then you will get the output accordingly. And you can't tell that until unless you allow the expression to go through the process. For now, you won't be able to tell, but later on you will be. I'll tell you the technique later on. Now, the best way to go about it is, I'm going to tell you the main thing about it, which is the reverse of the expansion. Okay, after that, I'm going to tell you the proper shortcut method, which you're actually going to. Okay, all right.
Yes, sir.
Okay, now the proper method, which you won't be using in exam, is just for the concept purpose. Completing square, basically I'm trying to complete the square and obtain something like this. I know I will be able to obtain factors like this if I have something a squared plus 2ab plus b squared, isn't it? A
Yes.
squared plus 2ab plus b squared. Only then I will be able to write it down as a plus b whole squared. Remember? Let me just take you back to the identities. There you go. So a plus b whole squared was equals to a squared plus 2ab plus b squared. So in order to go from here to here, I should have an expression written in this format. If I have this, only then I'll be able to obtain a whole squared. Okay? Now,
Yes.
in order to rewrite the given expression, I'm not going to change the expression, like not changing the value of it. I will be only rewriting it, reshaping it into this format. Okay, now a squared, x squared can be written as x whole squared. So a is basically x in this case. Got it?
Yes.
Okay, the next thing is a again. So a in this case was x, so I'll copy it down here as it is. Now for the middle term, which is 26x, I've already got 2x. Now 2x times what will give me 26x?
13.
Nice. So I'm going to put 13 here. So b is 13, so I should be putting 13 here because that's b squared as well, isn't it? That's b and that's b squared. So b is 13. Now you need to check if 13 squared is actually 169. Is it?
Yes.
It is. So if that's the case, then simply a plus b whole square, I should be able to rewrite it down as x plus 13 whole square. Got it? So that's the main concept behind it for factorization purpose. But this is not how you're going to do an exam. In exam, you'll be using this method because you don't know what output you're going to get. Okay?
Yes.
Okay. Now, there is something which we'll be always doing no matter what the output is going to be. So first thing you need to check, what is the sign of the middle term? In this case, it's plus. So you know it's going to be the first identity, which is a plus b whole square. For example, if it would have been minus 26x, then it would have been a minus b whole square instead. Okay? In this
Yes.
case, it's plus, so I'll be using the first identity. So I know it's going to be something x plus something whole squared. Okay? X plus
Yes.
something whole squared. And then there's another thing which you need to do always, no matter what. This minus sign, always. This plus sign, I've told you, if it's plus here, you put plus here. If it's minus here, then you put minus here. Now this minus sign is going to come here in any case, in all the cases. Okay? You will put that here all the time. Here, and then plus 169. You copy this down over here. Sorry, I forgot to put square on here. Got it?
Yes.
Okay, so what I've done is I'm going to do it again. So x, copy the sign from here, which is plus. So x plus something whole square minus something whole square. And then whatever you have here, copy it down as it is. So it's plus 169. So I'm going to write plus 169. Now, what is going to come here in the blanks? Whatever you have here, the half of it. So what's half of 26?
Um.
13.
13.
So
Yes.
you can put 13 here, 13 here. Now in the next step, x plus 13 whole square minus 13 squared is 169 plus 169 will cancel out and you will be left with just x plus 13 whole squared. Got it?
Yes.
Now why would you be using this particular method? Now for example, you have a question like x squared plus 3x minus 5 and the examiner wants you to apply the completing square. Now, by following the same procedure, what I'm going to do is check the sign is plus, so I'm going to do x plus something whole square minus something whole square, and then I'm going to copy this down as it is, which is negative 5. Now, the half of 3 is 1.5, or simply write it down as 3 by 2. Now, over here, x plus 3 by 2 whole squared minus 3 squared is 9, 2 squared is 4, and then minus 5. So 9 by 4 and 5. So basically I'm adding them. So 9 by 4 plus 5. So that's going to give me negative 29 by 4, x plus 3 by 2 whole square minus 29 by 4. So what this thing here is the second possible outcome here of the completing square. Got it?
Yes, sir.
Okay. Now there is one more precaution about this. Whenever you're applying a completing square, you need to make sure that the coefficient of x squared is 1. If it's not, then you will take whatever coefficient is as common. For example, if I had 2 over here, you will take 2 common from the entire expression first and then apply this procedure.
Okay.
Okay?
Yes.
All right. So this was completing square method. Now I'm going to write down an expression which is non-quadratic, and that is x cubed plus 11x squared plus 30x. Now it's 3 terms, but clearly it's not a quadratic. See there? If it's 3 terms and non-quadratic, then what do you do? Take
You
common.
take common.
So over here, I'm going to take x as common. So I'll be left with what's common from all 3 of them. It was just x, okay?
Yes.
So I'll be left with x squared plus 11x plus 30. So although it is factorized, but if you look carefully at the second factor, this one. It is further factorizable, isn't it? It's three-termed factor, and it's a quadratic. So you will be applying a middle term breaking on just this part and further factorizing. Okay?
Yes.
So you need two numbers. When multiplied, you should get positive 30x squared, and the sum of the two numbers should give you 11x. What are the two numbers?
For 30 and 11.
2 times?
15.
Next.
3 times 10.
Next.
5 times 6.
That's it.
That.
Which one?
5 times 6.
Nice. So it's going to be x squared plus 5x plus 6x plus 30. And that should give us x times x plus 5 plus 6, and then x plus 5. X times x plus 5 times x plus 6. Okay?
Yes.
Got it?
Yes,
All
sir.
right. Okay, now I'm going to give you an example of same type of question where you factorize it, but factorization is not done yet. You keep on factorizing until you see you won't be able to factorize it. So here's an example, and you will help me do that. X to the power 4 minus y to the power of 4. It's just two terms.
Um, can we use one of the identities on this?
Yeah, we've got two terms. There's a minus sign. The first thing which we are going to check is if we can rewrite them down as a square, or difference of squares. Can you?
So yeah, like x squared whole square, and then y
Yeah,
squared whole square.
so I am able to do that. So I'll be applying the third identity. What is that?
The third identity is like the x squared minus y squared whole square.
No, a squared. There's the third identity. A squared minus b squared. Factors are a
Oh, you're right. I got it.
plus b times a minus b. Whole square is a different story. That's a squared minus 2ab plus b squared. Okay?
Yes.
Okay, so yeah, what were the factors for this one? X squared minus y squared.
And then x squared plus y squared.
Nice. So it's not, we're not done yet. If you look carefully, which one of these can be further factorized?
Both of them.
Both of them, okay. How?
1 second, sir. Let me just. We can do. We can only do the negative one.
Yeah, just this one, okay?
Yes.
All right, what were the factors of it?
It'll be x minus y into x plus y.
Mm-hmm.
And this is x squared plus y squared.
Nice. Now your practice should be such that in exam you shouldn't be needing a guidance to know that you need to still focus if and check if either of the factors are further factorizable or not. Okay?
Okay.
Because the examiner will never tell you this. You will have to look at on your own. All right. So in order to know it better, the best way is to know all the rules very strongly and have a lot of practice. I'll share this document with you after the class, and what you can do is practice the factorization part by putting simply this part of the document in front of you and see for what question what rule is being applied here. All right, now one of the critical cases, sometimes you have three terms and it looks like non-quadratic, but if you make some changes in it, it becomes quadratic. That is known as coded quadratics. Okay?
Yes.
All right, now for example, let me just share an example with you. Yeah, I can see a couple of questions of that as well. All right, now for example, you have a question 2x to the power 4 plus 14x squared plus 24. Now, this is clearly not a quadratic, isn't it?
Yes, it's not.
It is not. But any three-termed, now that's important point. Any three-termed expression can become quadratic if one of the power is half of the other one. If you look carefully, one of the power is 2 and the other one is 4. So clearly this is half of 4, isn't it?
Yes.
So even if you have something like this, 2x to the power 10 plus 14x to the power 5 plus 24, you should be able to change this into quadratic. Now, how to do that? Now, simply, you will be using simple mathematics. What are you going to do? Now, this equation, this expression is in x, so you're going to introduce a new variable. Let's just say y. So you're going to assume that x squared is equal to y. If x squared is equal to y, then in a for this one to be quadratic, if I have y over here, what should I have here?
Also y.
No, in a quadratic, if I have y, just y here, what should I have here?
Oh, y squared.
Y squared. So if I take square of this, what do we get? X to the power 4 and then y squared, isn't it?
Yes.
So we are going to assume this. Let x squared equals to y, then x to the power 4 equals to y squared. Then I should be able to rewrite the same expression as 2y squared plus 14y plus 24. Now you can see it is quadratic, isn't it?
Yes.
Now you're going to apply the same rule. 24 times 2 is 48. And now you need two numbers, the product of whose is plus 48x squared. And the sum of the two numbers should give you 14y. The sum of the two numbers should give you 6 times 8. What is it? 6 times 8 is 48, and the sum is 14. Yeah. 6x times 8x, isn't it?
Yes.
So I'm going to rewrite the same one as 2y squared. Oh, sorry, it was y. 6y, 8y, 6y, 8y. So 2y squared plus 6y plus 8y plus 24. Now 2y is common, and then y plus 3 plus 8 is common, and then y plus 3. Now y plus 3 is common, and then you will have 2y plus 8. Now if you look carefully, I can factorize this one further. There are two terms. We have a positive sign, so we can take common, 2 as common, isn't it?
Yes.
So that's going to give it, if I take 2 as common, it's going to come outside. So that's going to give us 2 times y plus 3 times y plus 4. Now I'm going to revert it back to the original. Y was x squared, so I'm going to replace each of these y's with x squared. So 2x squared plus 3 and then x squared plus 4. This is your final answer.
Okay. Got it too.
Got it?
Yes.
All right. Now, for example, if the same question was as 2x to the power 10 plus 14x to the power 5 plus 24. Now, it doesn't look quadratic, but if you follow this, any three-termed expression can become a quadratic if one of the power is half of the other one. Now, you can clearly see this is 5, it's half of 10. Then we assume that x to the power 5 is y. If I square it, then x to the power 10 would become y squared. Okay?
Yes.
All right, great. Now, this is about factorizing. This is all about it. All right, now the next thing is, which is important, which you haven't actually done in O levels, is rationalizing. How to rationalize a given expression. It's about simplification. For example, if you have a to the power minus 2, for example. Now, the better way to write this down, the best way or the simplified way is always to write down a number with a positive index. So it's not, so by following the rules of indices, I'll take this in the denominator and rewrite it down with a square. Okay. Now, there's something about the square roots that if they are in the denominator, they don't look good. Okay, so there are basically three rules about rationalizing. One of them, the first one is if you have just one thing under the under root in the denominator, for example, let's just assume it's x, let's just say it's a, you multiply and divide with the same number in order to simplify it. So this thing is called rationalizing. Let me just change this color. It's not part of the question. I did this on my own in order to rationalize it. Okay?
Yes.
Okay. Now, next is if you have something plus with the root of it, you have the root and the denominator, but there is something being added here. It could be under the root or it could be just without the root. Okay?
Yes.
This thing, this is the first term of the denominator. It could be inside the root and it could be outside. But one of them, if even just one of them is inside the root, then what? Then you will be multiplying the same thing. Okay, now let me just give another number to this. Let's just say it's b. So I'll be multiplying the same thing, but with the opposite signs in between and dividing the same thing as well. So b minus root of a over b minus root of a. Okay?
Yes.
All right. Third is exactly the same thing, but with the minus sign over here. I'm going to need to change the sign because that's what I did on my own. That was not part of the question. Okay, going back. If I have same sort of situation, but this time I have a minus sign in between, now I'll be multiplying again, but this time, again, the main thing is to multiply whatever sign you have, you multiply it with the opposite sign, okay? Plus
Yes.
root of a over b plus root of a. Now, for example, you have a question. Let me just pull out a question for you. Yes, I found it. Now, for example, you have a question. Root of 2 minus root of 3 over root of 3 minus root of 2. Now, you see this?
Yes.
I told you about the first one. It could be under the root and it could not be. So that doesn't matter. What matters is there should be a root inside in the denominator. Okay? There is
Yes.
one, so I need to multiply the same numbers but with the opposite sign. I'll be multiplying and dividing the same number with the opposite sign. Now, if you look carefully, I'll be multiplying these two. This is root of 3 plus root of 2, and this is root of 2 minus. Okay, if I can I rewrite this down, this one, by swapping them? Would it matter?
No.
Like root of 2 plus root of 3, a plus b or b plus a, does it matter?
Um.
A plus b is same as b plus a, isn't it?
Yes.
So I can rewrite this down as just the numerator part, root of 2 plus root of 3. I'll tell you why
Yes.
So I'm going to rewrite this down as root of 2 plus root of 3. The reason is this is a minus b times a plus b. Now, if you recall the third identity, if you've got factors like this, the expansion would be a squared minus b squared, isn't it?
Yes.
Or just in case, if you don't figure that out, if you leave it as it is, the way it was, I just figured it out before expanding it, that it's actually the same. So then all you have to do is multiply them the way you normally do it. So root of 2 minus root of 3 times root of 3 plus root of 2 over root of 3 minus root of 2 times root of 3 plus root of 2. Down here is already arranged, and you can clearly see it's already the identity is being applied directly without doing any swapping. So the numerator part, you will be expanding it as root of 2 times this, isn't it?
Yes.
This root of 2 times all of this, so root of 2 times root of 3 plus root of 2, and then minus root of 3 times this as well, and then minus root of 3 times root of 3 plus root of 2. So what I've done is I multiplied this with this first, okay? And then I
Yes.
multiplied negative 3 with this first, then later on, okay? In the denominator, I'm going to apply the identity because I figured it out directly over here. So a minus b times a plus b is going to be a squared minus b squared. Even if you don't figure that out in the denominator as well, so you can do the exactly same thing, expand it exactly in the same way the way you're doing it in the numerator. Okay, but in the denominator, like all the time, you will be able to do it because what you're doing is you are multiplying the same thing with the opposite sign. So it's definitely the third identity will be applied directly. Okay.
Yes.
Now root of 2 times root of 3, you can rewrite it down as root of 6. Okay.
Yes.
There is multiplication sign. That's why you can rewrite them down under the same power. Let me take you back to the rules of indices. Different bases, same power. Where is it? Over here. Different bases, same power. You can rewrite them down under the same power. Okay, just for the multiplication and division. It doesn't work for addition or subtraction. Now we've done the same over here, but different bases, but powers are exactly the same. So I was able to rewrite them down under the same power. So you got root of 6. All right, root of 6, and then root of 2 times root of 2 is basically root of 2 squared. So you just left with 2. Got
I
it?
got it, sir. Yes.
And then negative root of 3 times positive root of 3 is negative root of 3 squared. So you'll be just left with 3. Root and square will be cancelled out. Negative root of 3 times root of 2 is going to be negative root of 6. Now, over squared and root cancel, squared and root cancel, 3 minus 2. Now, these two cancel. 2 minus 3 is 1, and 2 minus 3 is negative 1. 3 minus 2 is 1, and you are just left with a negative 1. Oh my goodness. Okay, it's not always 1, but it's just this question by chance, you're just left with 1. Okay?
Yes.
Was it difficult?
No, a little confusing, but it's fine.
Okay, no worries. Should I do one more question?
Yes, sir.
All right. So let's just say you have 5 root of 2 over root of 8 minus root of 7. Okay, now in order to rationalize this, I'll be multiplying it with root of 8 plus root of 7 over root of 8 plus root of 7. Okay? Now in the numerator, I have root of 5 root of 2 times root of 8 plus root of 7 over. Now this is, okay, I'll expand it a little later on. Root of 8 minus root of 7 times root of 8 plus root of 7. So this is a minus b times a plus b, isn't it?
Yes.
All right, so we'll be applying the identity in the denominator, but we won't be able to do the same for the numerator. So in the numerator, 5 will stay as it is. Root of 2 times root of 8 is root of 16, isn't it?
Yes.
And root of 16 is 4.
Yes.
So that I'm left with 5 times, because this whole thing is being multiplied with this. So 5 over here, root of 2 times root of 8 gave us 4. All right, plus, again, 5 as it is. Now root of 2 times root of 7 give us root of 14 over a squared minus b squared. 20 plus 5 root of 14 over 8 minus 7, which is 1. 20 plus 5 root of 14, that would be your final answer. Got it?
Yes, sir. Got it.
All right, so I'm going to leave you with one of the questions. I would like you to do it on your own. In the meanwhile, I'll check on the door. 11 over 3 plus root of 11.
Okay.
Handy. Can you open him?
Yes, I got him.
Can you see him?
Yes.
Nice. Oh, I forgot to check your question. Okay, so 3 negative root of 11 over 3 negative root of 11. 33. Good. 3 square is 9 minus 11 negative 2. All right, good. But just one more step. You take the negative sign in the numerator, so that's going to change it to negative 33 plus 11 times root of 11 over 2. Or you can rewrite it down as 11 root of 11 minus 33 over 2. Got it?
Yes, sir.
Okay, now there's an exam question which came in exam. 2 root of 5 over root of 5 minus 1. Now don't get confused that you had this root of 5 over here before. Don't get confused with it. It's exactly the same thing. The main thing was you should have a root in the denominator. So you'll be doing the same. This plus this over this plus this. Okay?
Yes.
Okay. I think this is it for today. We'll have another class tomorrow. I was thinking to go through 2 chapters today, but longer than expected. This was just first chapter.
Okay, sir.
Can you practice all the questions before tomorrow's class?
Yes. Yes, for this chapter.
Yeah, the first one. It was chapter
Okay.
number 1. Okay?
Yes, sir.
All right. See you tomorrow. And congratulations for the iPad.
Thank you,
I'm
sir.
happy. I don't know why I'm happy, but I am.